So friends, this is in context to the two earlier published video involving the basics of chromatography, TLC and paper chromatography. In this continuation of the earlier two videos, we are now going to discuss a very important tool in chemistry, especially an industrial tool, that is HPLC, which can be coined by two different names. You can either call it high performance liquid chromatography or you can coin it as high pressure liquid chromatography. This is one of the most anticipated topic in the chemistry, and way back in 2015, Government of Gujarat through the medium of Baizag and Sandan has already recorded this video, but it was in the regional language Gujarati. Since then, it was a huge demand to make the same into the language English, but there were many associated things with that, and so now it is the right moment when the series of chromatography is under recording. I had this opportunity through the collaborative efforts of Shateman Science College Patan and Dipam Foundation to serve the students the online education. Henceforth, we are here with this topic. If you see, today's discussion will involve these following topics, which are already flashed on the screen, hence I won't waste any time deliberating them again. If you go to the introduction behind chromatography, it is very well mentioned in several books that it is nothing else than a physical technique which is used to separate compounds or separate something from the mixture. So it is a separation method and not an identification method at an initial stage. So chromatography is an analytical method used to separate compounds physically prior to measurement. It very much involves our attention towards breaking of physical bonds. It satisfies the purpose of separation and quantification of the target. You will be able to know what is separated at a later stage, how much quantity is separated. But in few aspects, you need to attach some other instruments. But now, sticking to the topic, we'll only stick ourselves to chromatography and so on. The history behind chromatography lies in a very purposeful experiment prepared and done by a Russian botanist Mikhail Svet. As you can see on the screen, he took a big column, added to that column a solution prepared by dissolving maximum amount of the extracts from a leaf or a bunch of leaves. What he did, he collected some leaves, washed it carefully with water, crushed them and added petroleum ether to it. After a proper stirring, some of that extract were collected in ether. He just passed it through the top of the column. Mind well, the column was filled with some solid material that was calcium carbonate. Nevertheless, the basic education says that chlorophyll is a component of leaves and the component responsible for the green color. So it was mandatory to have a green color patch in the column. But apart from this green color patch, Mikhail Svet in this basic experiment could recognize few other patches, and which gave him an idea that there are more than one component present in this extract of petroleum ether. From where he could conclude, or he could come to a little conclusion, that there is not a single component present in the leaves, there might be other components also. This is how he got an idea of a physical separation. Let us see that. Calcium carbonate is a material solid filled inside. When this ether containing extracts passed through it, different components got separated physically. And this is how he got an idea. Different color patches were called chroma, and if you tilt it 90-degree on an axis, you can get graphs. So you can coin it simply as chromatography. There are some important terms associated with chromatography. They include stationary phase, mobile phase, chromatogram, and retention time. And if you see very carefully in this graph, or rather to say in this picture, this calcium carbonate is a solid material filled inside, and hence we would coin it as a stationary phase, a phase or a part in the experiment which is immobile. At the same time, petroleum ether containing the extract will move from the top to the bottom, and hence it is the mobile part. Coming to the chromatogram, which will be discussed at a later stage of this video, and retention time, which needs to be explained now. The time taken by a component from the top end of the column to the bottom end of the column is generally termed as retention time. This can be explained in this slide also. If these are the components, then the time taken by the red component from this end to this end is called the retention time. As of now, the retention time for the blue component cannot be measured completely because the blue component has not reached the bottom of the column. So this is what retention time is. So we are very clear with the stationary phase, we are clear with the mobile phase, we are clear with the retention time. Initially, after the performed experiment of Bickel-Sweat resulted into a basic experimental technique called chromatography. On the screen, you can see some of the parameters for a column, its diameter, its length, packing material, which is fundamentally a stationary phase, and the size of the packing material. Size matters a lot. We'll come to this. But over here in a picture, you can see three columns. Mind well, they are not three different columns. These are different pictures of a same column collected at different time. The column on the extreme left of the viewer is the snap of the column initially. The middle column is photographed after a minute or so, and the extreme right column is photographed at 5 or 7 minutes of the experiment. What does it help us to learn? The blue color part filled inside, that is the dark blue color. This one is the stationary phase, silica powder. On the top, another liquid-like material is the mobile phase, and this orange color inside, which won't be visible in all the experiments, is a mixture of more than one compounds, matrix. When it passes through the column, due to some or other interaction with the stationary phase and the mobile phase, this orange color mixture gets separated physically. You can see in the extreme right photographed column that these two components are separating. This will draw you back to this slide where you can read very precisely. It is an analytical method used to separate compounds physically prior to measurement. So it's a physical separation. Now, column chromatography was there. Nevertheless, there were some drawbacks of this technique. What were they? Separation is not efficient, more time consumption, and wastage of solvent. We'll just think of each one a little because it is essential. See, when we say separation is not efficient, over here the separation is efficient. There is an ample distance between the yellow dot and the red dot, the two compounds. But there might be some experiments where the mixture will reach from this end up to this end, and the distance between these two compounds won't be efficient. Means when you are collecting the red in a vessel, few drops of yellow might come in. This in a scientific term is called inefficient separation. This experimental technique, the flow is from top to the bottom, which is fundamentally the force of gravity. You cannot rather increase or decrease this gravitational force, and hence it will work on its own. So how much time it would take will be natural, it might be more. And wastage of solvent, because this is a column which is 1 meter in length, you can see, and 5 centimeter in diameter. So taking this volume and area mathematical formula, you can calculate the quantity of mobile phase required. So owing to these drawbacks of column chromatography, there was a need to develop something which could overcome all these drawbacks. And scientists, after gathering these informations, had an idea of doing something different, and that different was HPLC. Now the question comes, why only HPLC? Why other techniques could not do this? See, when HPLC came into existence, what were the different aspects which could help us to deliberately say that yes, we have overcome the drawbacks? Lesser time consumption, less use of solvent, efficient separation, high sensitivity and resolution, and small sample size. If you could get all these things possibly done, then industry and the scientific fraternity wasting an ample of time and money for research and serving the society needs this. Hence, HPLC was a technique. I am using this term was a technique because now we are at UPLC. But HPLC is that thing which is needed to overcome these old techniques. So, lesser time consumption, less solvent, efficient separation is okay. But coming to the point, high sensitivity and resolution. It means it can also detect a very less quantity of sample. Hence, I have mentioned it. Sample size to be very, very small, that is ppm or ppb, and a good resolution. These are few scientific terms that are associated with HPLC, and we will come to them as and when we move on with this presentation. A very important question to be addressed at this moment is why high performance, why high pressure? I told you earlier that in this column chromatography experiment, the movement of this orange mixture from top to the bottom was all dependent on gravitational force, and hence it took a large amount of time consumption. When HPLC came into existence, you had a fundamental principle of pressure which could be applied either by throwing pressure from the top or sucking from the bottom. Sucking from the bottom requires vacuum, and throwing pressure from the top only requires pressure. So, in HPLC technique, pressure was exerted from the top, and hence the sample and the mobile phase moved comparatively faster than in the column chromatography. So, this is how we could justify the term pressure. Coming to the term performance, it can be justified using two different terms, that is accuracy and sensitivity. Sensitivity, fundamentally speaking, we have already discussed that a very less quantity of a sample can be sensed and analyzed and separated. But what about accuracy? I will give you a very small, precise and a beautiful example. If we are in a laboratory of an undergraduate or a postgraduate and our students are asked to perform basic titration experiment, if I say very purposefully, most of the students undergoing this experiment will get 3 readings after pilot 1, 2, and 3. Nevertheless, we all know how much accurate we are, and also we write 10.3, 10.3, 10.3. But thinking on a very correct way, very few students will get this correct. But this machine, for a sample analyzed in a particular ambience, if reanalyzed after a span of time keeping the same ambience, will have the minimized error and the same answer by digits. And hence, we could justify it by saying high accuracy. So, it is highly accurate, highly sensitive, and therefore, we could justify it to be high performance. Hence, we can write it to be high performance liquid chromatography. We are sorry that the H has been hid behind this index part, but it is H of high performance. Now, what is the scope of HPLC? As I told you, it's one of the most important tool in industrial chemistry or chemistry, but it is not restricted to chemistry. There are n number of industries using HPLC. They include pharmaceuticals, biochemicals, food products, industrial chemicals, forensic chemistry, and environmental science. In one way or other, these are those industries which are using this technique. Pharmaceuticals in their qualitative analysis, in their R&D, food products, they are also using the same. Forensic chemistry for the identification of the content of alcohol in blood, environment science for the detection of gases in environment via gas chromatography. So somewhere or other, HPLC or other associated techniques like gas chromatography are used somewhere or other. If I speak prominently for a second on environment chemistry, the content of pesticides in the river water or in the pond water is identified by HPLC. So friends, these are the scopes that you are listening to the video, you are investing your time, you are investing your precious moments sitting at home listening to the video. What would be benefited? If you are aiming some of these areas, I am sure this talk is going to be useful to you at all stages of your life. So what is the concept and mechanism behind this technique that we are learning as of now? If you look at it, separation of compounds take place as they move at different rates in the column. It means at the initial stage both compounds are together, but when they move in this column along with the mobile phase, one compound is moving faster compared to the other. It means there is some interaction going between the blue component and the column in a more connective way compared to the red component in the column. So if we have this description in the form of a graph, the one that comes out first will be identified first. So in the graph we will get the red annotation first, followed by the blue. But the thing is, what is that concept behind it? I'll explain in this beautiful interactive mode of presentation. Due to different interaction between the sample and the stationary phase, molecules move at a different rate. Friends, students, academicians, researchers, in this stanza of two lines or three lines, I have mentioned that due to different interactions between the sample and the stationary phase, molecules move at a different rate. It is one of the parameters that is needed to be discussed now. But mind well, there is always an interaction between the sample and the mobile phase also. But for this complete set of video of chromatography, we will be concerned to keep mobile phase only as a carrier, and all the answers that we will give or discuss will be based only conceptually on the interactions between the sample and the stationary phase up to this discussion of HPLC on chromatography, which is partially correct, but is the basic which is needed first. The direction of mobile phase is from left to right. So we are just going inside the column. When we go inside the column, we could see the two components that are placed from the left when are moving inside the column. The red component moved a little faster and the blue component was moving a little slow. This could draw our attention that the red component moving at a faster rate compared to the blue component moving at a lower rate is on the base of the interaction that they are having with the stationary phase. There is some weaker interaction between the red molecule or the red component with the stationary phase compared to the blue, and therefore the red component did not fit itself in the environment of the column and moved faster, whereas the blue component got itself fitted inside the stationary phase and is moving behind slowly. So this is the concept mechanism behind the working of chromatography, especially HPLC, and mind well when we consider absorption as the base and not any other mechanism. Because if you go to the first video where chromatography was discussed, after the complete classification of chromatography, we could come to a conclusion that there are two modes of mechanism behind any technique used in chromatography, of which one mechanism was absorption, one mechanism was partition. Yeah. And when the stationary phase is considered to be solid in general, we go for absorption mechanism, which we are doing here. So friends, this is how the interaction phenomena helps us in determining the rate of different components in a matrix. So you might have got an idea that when we start the two components, then both should reach at the same time, but this does not happen. One component comes out faster and the second one is coming out slower because of the different interactions that are going inside the column. So built on this mechanism is this technique of HPLC. So this was the first part which has discussed the introductions and the basics, why we need HPLC, why pressure and why performance, what is this concept and the scope of HPLC. And now we are coming to this important part, instrumentation. But I want to again cut these videos into small part to make them upload easily. So I'm pausing over here with this first part of part 3 chromatography, and very soon I'll start with this slide, that is instrumentation. Hope you are very clear with this first slide. Although if you find any difficulty, you can write me on my email as well as my mobile number, which will be shown to you or flashed in the last slide of the part coming up. Thank you.